everybody. Thank you for joining. Thank you for joining the our webinar. I'm Mark Ainsworth. I'm representing the BCS Preston and District branch this evening, and we've got a really interesting evening. And we're lucky to have Dr. Andy Lowe, who's going to give us a presentation about human-centric AI, and then we've got an opportunity at the end for a Q&A session. In terms of how that's going to work, the Q&A session, hopefully you'll see in Zoom, you will see a chat window. So please do, during the presentation, please do add any questions that you've got, and then we'll raise them with Andy. I will go through them and try and keep an eye on what questions are being asked, and then we'll go through and I'll pass those questions on to Andy. And we'll aim to finish by 7 o'clock this evening in an hour's time. Just as an introduction, in our Preston and District branch members survey last year, AI, artificial intelligence, was certainly one of the hot topics that a lot of people were interested in hearing more about in future events. So we listened and we did this. We managed to arrange this, and thanks to Andy for giving us the time, his time this evening. I was lucky to meet Andy 2 years ago when I was taking the BCS Foundation Certificate in Artificial Intelligence. We were just before this call trying to work out whether it was the first or the second group that managed to take it in London. So I was really lucky to have that 3-day course that was really comprehensive and very informative and interesting. So I've got great hopes, no pressure on the next 45 minutes. So without further ado, Andy, I'll hand over to you.
Thanks, Mark. It's nice to be here. Thanks for inviting me, and it's good to see you again. Wednesday night, it's not raining. I live in the Lake District. It's not raining, fortunately. What I'd like to talk to everyone about tonight is human-centric AI, which is slightly different to what we normally think about with AI. I have a PhD. I'm an engineer by trade. Just to tell you what I give you a little bit about my background. I'm an engineer by training. I started my AI or machine learning as an undergraduate, doing operational research and numerical analysis at UMIST, and then I went off and did a PhD in computational fluid dynamics and learning from data or machine learning areas. Then I went off to look at decommissioning of Britain's nuclear facilities. And that's where the real love of AI came in, because we were starting to look at how do we absorb all this information we have from all the different nuclear sites, absorb it, and then be able to teach it to future generations so that we can decommission all our facilities safely and sustainably. So what we're going to talk about today is making sense of AI's potential. It's not as easy as we think, and hopefully we'll get that across as we go through. So an outline for the talk. We'll first of all look at what artificial intelligence is, and then machine learning. Are they the same? Because often machine learning is used interchangeably with artificial intelligence. I'll hopefully get that across, that artificial intelligence is a much richer, deeper subject than machine learning. Machine learning is very important, so please don't get me wrong on that one. But artificial intelligence, as we go through, hopefully will gain more importance and become a richer subject for you to think about. We'll then go into human-centric AI, and this has been driven by the European Union's guidelines, which are now going to be written into the law. So we'll talk about what that means. We'll then look at intelligent entities, humans and machines together, and in particular a book that was written by 2 gentlemen who are management consultants, which is a great book to read if you're just first looking at artificial intelligence, because they've looked at about 1,000 consulting projects. And this is their learning from it. They're very, very experienced management consultants. We'll then look at some human-centric AI, real-world examples where we've really understood what humans can benefit, how humans can benefit and work with artificial intelligence. And then at the end, I'll give you some suggestions on the, instead of first hello world programs that you would do if you were looking at machine learning, let's look at Hello Human, AI Kickstarter projects where we're thinking about what the humans' involvement is going to be. So straight in. What is artificial intelligence? So our first point is AI is about creating intelligent entities, and humans are nature's best example. Apart from dolphins, of course, humans are nature's best example of intelligence. And we'll think about what that means in the next slide. AI has a very simple schematic, so we can relate AI to products and services, and maybe how machine learning fits into that. AI can take away the heavy lifting from humans and leave us humans to higher value activities. So that's really what we're about. When people talk about artificial intelligence, we want to kind of take away the monotonous, boring tasks from humans and leave us to higher value activities. Stuart Russell and Peter Norvig have written the standard textbook on artificial intelligence, and they tell us that artificial intelligence is a universal subject, a bit like mathematics, engineering, and philosophy. And in particular, they say it is based on the scientific method, so it's rigorous, it's robust, it's objective, and it's about learning from experience. So if someone comes along and says, do you want to, can you implement machine learning or AI into our company or into our club or activities, the first thing you ask yourself is, where's the learning from experience? Because that's what AI can help us with. So these are some definitions of what intelligence is, and we're going to wrap IQ and EQ into that. So intelligent quotient and emotional quotient. Concise Oxford Dictionary, it's the quickness of understanding, it's wisdom, it's the collection of information. Cambridge International Dictionary, the ability to understand and learn and make judgment or have opinions that are based on reason. So this is very much about knowledge. Wikipedia is a little bit richer and deeper. Problem solving, reasoning, self-awareness, creativity, emotional knowledge. So it's not just about capturing information and using it, it's actually problem solving, reasoning, self-awareness. The best one we found in order to teach artificial intelligence is from Encyclopedia Britannica, and it's from the psychology, human intelligence and psychology. And here the key phrase, learn from experience, we adapt, understand, we can handle abstract concepts, and we can manipulate our environment. So the two key things there are learning from experience and manipulating our environment. That's what we humans do. We use our intelligence to work with other humans and machines to change our environment, to make a better place, to feed ourselves, and so on and so forth. In the previous slide, we talked about this simple schematic. So that's what we'll look at next. So this is a very simple schematic of artificial intelligence. So it comes from Russell and Norvig again. It's a general learning agent. And so on the right-hand side, we have an environment where we're going to perform something or do something. And from that environment, our agent, which is the left-hand side, perceives what's going on. It's called a percept, and this is in our environment, and then we'll take actions on the environment based on our percept. So a very simple model there. The dotted line is something that we traditionally associate with engineering, robots or control systems. So we perceive something via our sensors, we'd use some performance element, a program or whatever to tell actuators to do something. So you might think of that as a robot or control system. And artificial intelligence is typically taught in engineering departments, and then it draws on engineering and as well as a whole wide range of other subjects as well. Then Russell and Norvig proposed something else, which is the learning part. So you might think of this very simplistically as the machine learning part. So this agent now is a critic, and the critic is telling, from reading the sensors, it says something to the agent about the agent's performance. The learning element is the bit that does the learning from the sensors and previous actions, and it'll change the performance element or this program that relates sensor to actuator operations. The bottom left-hand corner is the problem generator, and so when we've exhausted our existing strategy, then we might try something new. So what this does gives a very simple understanding of how artificial intelligence mimics humans, how we manipulate our environment, and the element on the left-hand side tells us how we learn from experience. It's quite a simple schematic, but it's very powerful, because then we can think about products and we can think about saver services. So we have a machine learning mindset. We're only really thinking about how do we work with data, or we provide services. Whereas when we think about the general AI schematic, we can now think about products or machines actually operating and working with humans. So what is machine learning? term was first used by Arthur Samuel from IBM in 1959, but Tom Mitchell's definition is more widely quoted. The field of machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. The second definition is an academic definition, and you can read it if you like, and it's a great exam question, but very, very boring. Learning from data is useful. It's very useful for engineers. So computer-aided engineering, where we design and build models, we generate lots of data where they need to learn from. But we need more than that, just learning from data, if we're going to build intelligent entities. I mean, that seems, you know, from a very simplistic point of view, machine learning is about learning from data. But when we expand that to generating intelligent entities, the actual aim of artificial intelligence, then we need more than just learning from data. So machine learning is one of the enablers of artificial intelligence. It's something that has driven almost huge worldwide interest in artificial intelligence. And it's based on basically machine learning. And we've been doing machine learning since the 1940s. Since Turing's papers and the breaking of the Enigma code, lots of people in the military realized that operational research was a very useful way of organizing armies to get into the theater of war. So we've been doing this now for about 80 years. It's a big part of the AI toolkit. Machine learning is the theory and practice of how computers learn from data without being programmed explicitly. This is Tom Mitchell's definition. It's useful on its own in understanding data. So everybody will have heard of big data, the Internet of Things, spam filtering. One of the most successful machine learning algorithms is filtering spam from our emails. Image analysis in health research. Researchers now have all the transferable skills to do machine learning. Most researchers will use computers, spreadsheets, other types of data processing capability in order to learn from their research. Engineering certainly uses it and has been using it for many, many years. Medicine is a great example of where you can use machine learning. Almost doctors and consultants use the scientific method daily in order to improve their outcomes for their patients. Machine learning is defined by the type of learning it undertakes on data. Learning from example is one, of course. There are lots of other types: supervised, unsupervised, reinforcement learning. These are the types of things that you'll learn if you go onto YouTube or to any of the cloud providers of machine learning packages. That takes us nicely to open source and transparent systems. So if you go to Google or you go to Microsoft or to Amazon, they all provide open source software that you can use. This gives you functionality, software and hardware. You can start using that today. It's usually free. So you'll get a free amount of time on their supercomputers, and all their code is optimized to run on their hardware. What they're really selling you is time on their hardware. They give you the functionality and software for it. It's very easy to get started in machine learning, but it's only part of the AI toolkit, and it's great that it's free. And other areas of AI, maybe robotics. Again, there's lots of open source, free, transparent software and systems that you can draw on. Machine learning is popular for analyzing large data sets. So business analytics would be one. Another one is the genome. So if we've got to do genetics in medicine, for example, we can't do that without machines. We need machines to help us with that. We just physically can't read everything or find all the correlations or any information from it without using a computer machine. So thinking about humans and human-centric AI again, contrast machine learning with AI examples. So home automation, robots, for example, home assistants, chatbots, smartphones, smartwatches. There's something more involved when we talk about AI rather than just machine learning and learning from data. So what makes us think about the humans? So the EU have written some ethical guidelines for trustworthy AI. This was an expert, high-level expert group. They were one of the first to write guidelines for artificial intelligence, and they came up with two things. Trustworthy AI has two components. It should respect fundamental rights, applicable regulation and core principles and values, enshrining an ethical purpose. and 2, that it should be technically robust and reliable. So even with good intentions, a lack of technical mastery can cause unintentional harm. So what we take from those guidelines is that we want human-centric AI that has an ethical purpose and is technically robust and trustworthy. When we think about that sentence, it's a lot more than just learning from data and machine learning and cloud supercomputing, all great things, but actually we need to think more deeply about what AI is when it comes to respecting the human. So what are the fundamental rights of human beings? This is enshrined in the EU Treaty and the Charter. Respect for human dignity, freedom of the individual, respect for democracy, justice and rule of law, equality, non-discrimination and solidarity, and citizens' rights. And this includes the rights of persons belonging to minorities. When you look at the guidelines, the ethical purpose has 3 parts to it: principles, values, and rights. So values are the one that really means something to us, because it's our values that motivate us. So if we get the right mix in our ethical purpose of principles, rights, and values, it'll be motivational to us. It'll help us make good decisions. It'll give us good and ethical moral values, and hopefully it'll be enshrined and protected in law. We can rely on it, and other people are going to protect us. So what are the ethical principles in the context of AI and corresponding values? Again, if you work in medicine, ethical principles and ethics committees are part of their day-to-day working. And generally what they mean is do good, do no harm, preserve human agency. That means preserve your independence and autonomy, be fair, the rule of law, and operate transparently. The great thing about open source code and that's provided by the supercomputing vendors, etc., is that it's transparent. And if you think about that, there's lots of forums, and if you're starting your project for the first time, you'll come up against problems. You can go onto the forums, and someone somewhere will have met that problem, and hopefully will help you through it. It's a very useful collaborative environment for us to work in. How do we do that? So this is a very simple flow chart. We start off with our ethical purpose. This gives us requirements for trustworthy AI. We'll go into a little bit of how you assess that in a minute. And then you use technical and non-technical methods to implement the requirements. And once you've done that, you continually evaluate and justify your AI system. So use, analyze, design, development. You go around in this circle, this cycle of inquiry all the time. So this is the sentence or the paragraph before the flowchart at the bottom of the flowchart is directly from the EU's guidelines. AI systems can help facilitate the achievement of the UN Sustainability Development Goals, such as promoting gender balance and tackling climate change, rationalizing our use of natural resources, enhancing our health, mobility and production processes, and supporting how we monitor progress against sustainability and social cohesion. So they're taking the idea of machine learning beyond just learning from data and applying it to without thought of the bigger picture. They want you to really think very carefully about how you're designing your artificial intelligence system, be it a machine learning or being in an AI product. Essentially, we need to measure what we're doing. So we can think about the 3 pillars of sustainability. We want to get back to the United Nations Sustainability Goals. So sustainability has 3 pillars: social, environmental, and economic. We want to be in the middle of those. If you think of it as a Venn diagram, we want to be in the middle of those. Want things to be sustainable. So this isn't a big exercise. This is just, we want to be always trying to do the right things and measure that so that we can show or demonstrate our human-centric ethical purpose. 3 big things that come out of human-centric ethical purpose are universal design. This means design for all. This is very much, you'll see this in buildings. We're trying to make buildings accessible for everybody, or you'll see the drop curve in roadways, so people who have difficult with mobility can cross roads. And sustainability is really about intergenerational equity, which means handing to the next generation something better than we've inherited. Climate change may not necessarily be maybe a consequence of our industry, the past industry for the 60, 70 years. We need to change that. There's a lot of focus on that at the moment. These are the United Nations sustainability goals. I won't go through them. I won't go through all of them. I'll just pick a few off. Decent work and economic growth is one. Life below water. Climate action is number 13. We want affordable and clean energy, whatever that means. Number 1 is no poverty. Life on land, trying to protect that. So we can pick, when we're designing our AI system, we can pick one of those goals or a group of those goals and start measuring or designing into our AI system something that benefits society financially, economically, and also environmentally. So the top right-hand corner is an image of the Sustainability Goals agenda from the United Nations. Our stakeholders are not just interested in sustainability, so they'll have their own measures as well. We need to be aware of those. If we don't start to think about sustainability or ethical purpose, we tend to obsess about money. Now, money does make the decisions, but actually we can evaluate, and we can still let money make the decisions, but we need to have a broader set of goals in order to make sure that we have a sustainable ethical purpose. Some typical business processes that you might have heard of, you've been to business school, is PESTLE, and this will again help you form this ethical purpose. So with AI, specifically about AI, learning from experience, what do we need? Well, we need 3 things: functionality, software, and hardware. So the functionality, what do we need to learn? We need to collect data, prepare data. We need algorithms to learn from the data. We need to present that data. And then we need to deploy the AI, product, service, or publish. So we have to wrap into our deployment of AI into the academic realm, because it is part of the scientific method, and we need to publish our results, whatever they are, so that they can be peer reviewed and assessed as part of the scientific method. We need software, and luckily the software's out there already. It's usually open source, so you can get that from Amazon, Google, Apple, IBM, Microsoft, a whole range of them. You can write your own. So typical programming languages can be R, Python, scikit-learn, TensorFlow, C++, Objective-C. Fortran, object-orientated, is usually helpful because object-orientated software tends to give you a way of organizing your data, this very important bit, so that you can use your machine learning algorithm. There are commercial software providers, MATLAB, Matrix Laboratory. So a fundamental part of machine learning is linear algebra, and Matrix Lab or MATLAB is a really good way with a GUI WYSIWYG interface to do linear algebra. You've got Microsoft Azure, IBM Analytics, Google Analytics, AWS as well. And then you need hardware. And we need the hardware for the software, but we also need hardware if we're building an AI product. So an AI product will need actuators and sensors to interact with its environment. We might use a high performance computer, and the great thing, one of the enablers of AI has been cloud. So I can log on to AWS and I can have a 6, 8, 128 processor machine, and I can run it overnight, but I don't need a massive infrastructure of a high performance computer or the cost of that. It's usually roughly about $1 for 10 processors per hour, roughly speaking. You can have your own computer cluster. If you've got an office with lots of computers, you can use your desktop computer, tablet, or smartphone. Interestingly, most people walk around with a smartphone now, and I think it was the iPhone 7 had enough mathematical operations capability to beat Garry Kasparov at chess. So it has the same flops as the supercomputer built by IBM to beat Garry Kasparov in the 90s. So essentially, we have supercomputers in our pocket. So how do we move on? Well, humans and machines working together. So humans and machines, and by machines, we mean intelligent entities working with nature's most intelligent entity, which is humans. And we're going to have to work together. So Paul Doherty and James Wilson have written a book, Human plus Machine. It's part of the Harvard Business Review. They are Accenture management consultants. And they proposed the missing middle, where humans and machines experiment and work together to define a new reimagined future. And this is based on humans complementing machines. So we have to train the machines. So if you've built a a robot that does surgery, the consultant surgeon has to train them, and there's obviously going to be an AI expert and engineers as well. They need the data and the experts to train them. We'll need people that can do the explaining, explain how the machine learned. So that might be quite easy with a decision tree, but more complicated with a neural network. People are now working on ways of using neural networks to understand how they've come to the solutions they have or the answers they have. Sustainers, these people make sure machines are acting appropriately and are not being misused. So in the health setting, you may have an ethics committee, and you may have an AI ethics committee as well. So at some point we may come to at some point in the future in your careers in AI, you may have a situation where the AI is going to have to make some decisions, taking away the autonomy or agency away from people, and that can be tricky to prove or to justify from an ethics point of view. So ethics committees are really helpful in that sense. Human augmentation, we gain superpowers. So a search engine, for example, is a great example of that. We can now do a world-class literature search from our desks I'm being a little bit facetious, in a matter of seconds, whereas traditionally academics would travel around the world and it could take them decades to collect all the papers they needed in order to justify their hypothesis or their research. So Amplify, we can now have tools to enhance our abilities, design, space exploration. So extreme environments such as subsea, deep subsea, or highly dangerous chemical environments or space, etc. We can build AI tools to help us explore those environments. Interaction, AI agents interact with humans to leave humans to higher value work. These can be chatbots, really simplistic ideas, but could unlock a lot of value. And there's some great examples in a book coming out from BCS on autonomous organizations, where they talk about a local council that has embraced AI agents to interact with the people that live in their council, in their area. Embodiment, this is robots and humans working in harmony. They're aware of each other and they enhance each other's abilities. So you could have someone working in your house who has a robot that understands that the craftsman needs a piece of plasterboard on the roof, so it picks up the plasterboard and places it for the craftsman, who then cuts it out and screws it to the roof or whatever. We can build robots to do that. Another example that they use in the book is where we use robots and humans to build our cars, because we want cars now to be individual. We'd like to select the color, air conditioning, the type of stereo, whatever. And production lines tend to be very efficient and they don't like change. So in order to adapt to that, large car companies now are using robots and humans working in harmony in order to produce the cars that we ultimately want. Okay, so this is some examples of where people have really thought carefully about humans and machines working together, or AI and humans working together. So biophilic design, this is an architectural example. Biophilic means that we bring nature into our buildings, which makes a more calming place, a healthier space for us. But in Singapore's Jewel Shang airport, they also have machines going around, and the machines entertain children who are waiting for the aircraft. They clean, they direct traffic, they monitor the environment, they provide food and distribute food. There's a whole range of artificial intelligence that's been designed into this environment based on how human would like to interact with the airport. The next one is a large organizations, Rolls-Royce. They've got their jet engines anytime, any place, anywhere. So Rolls-Royce have completely transformed their business, their large organization. They've thought about what their stakeholders need. So they've not only thought about the customers, they've thought about the airlines, they've thought about the shareholders. And they realized that their jet engines were being used by many airlines. Each airline would manage their own jet engine. So that means doing the maintenance, if there's any upgrades or they bought a new engine, all that kit would have to be upgraded. So Rolls-Royce were all not only providing the engines, but they were also providing all the facilities and all the training to support the engines by the airlines. So instead of that, Rolls-Royce developed almost like a nervous system for the engine, so that they could learn from the engine and monitor the engine anywhere they wanted. And they now manage all of their engines from Derby, and aircraft people, the airlines now don't have to provide the maintenance facility. They don't have to learn about the new engines. They just rely on flight hours from Rolls-Royce. So Rolls-Royce now manage all of their engines. They give airlines flight times. The airlines now can concentrate on selling seats on the airplanes and flying the aircraft. Rolls-Royce do what they're good at, which is learning from the engines and managing that engineering kit. If an engine's beginning to fail or it needs a new part, they can fly out the part to where the aircraft is, maintain that aircraft, and then the airline carries on again, or the aircraft carries on again. It's a complete transformation of their business. They make more money, and the airlines make money, and the customers get more reliable engines. It's a fantastic example of a large organization that took learning from experience and revolutionizing their business. The next one is an individual. He's Todd Stablefelt, or hashtag the Quad Father, and he coined the phrase "convenience for you is independence for me." And it's better to go and watch his video at the Apple Developer Conference in 2017. The link's there if you want to see it. Todd Stablefelt is a quadriplegic man with a personality and a drive to inspire us all. His platform is about making convenience a route to independence for him and millions of others. He has a passion to experience being human to the fullest he possibly can. As a quadriplegic man, he can only move basically his neck and head. And this occurred because he was shot when he was quite young. I think he was about 7 or 8. He was brought up in the 70s. He was accidentally shot by his friends when guns were more freely available. He was shot accidentally and he became paraplegic. He now runs his own company, inspires millions of developers to write more accessible applications that give people of all abilities better lives. This is now evolving into using AI products and services to live a fulfilling life. So when you watch the video, you'll see him talking about his early experiences where he got his first job as a database manager, and then he realized that he could use his wheelchair and some accessibility actuators and the iPhone to live a more fulfilling life. It's better if you go and watch it because it can get quite teary. It's very emotional, but it's a great inspiration of how he took his human experience and then adapted that using AI technologies to live a more fulfilling life. So how do we get started with human-centric AI? We've got the enablers in place. We've got cloud supercomputers, the World Wide Web. We've got access to data, free open source code. And that doesn't mean just machine learning from data. If you want to develop products, there's ROS, which is the robotic operating system. So you've got sensors and actuators if you want to develop a product. We've got GPUs and CPUs in our laptops. But you can, again, get access to the most appropriate hardware to solve your problem in the cloud providers. They'll even go as far now as giving you access to quantum computers, which is another step beyond digital computing. You've got access to hardware, sensors, and actuators. AI needs functionality, software, and hardware. The bit we're missing really is the functionality part, the humans and machines in harmony. So we need something a bit more than just, I need to do a quick search, I need to solve this equation, I need to do some reinforcement learning. It needs to be more than that. We need what's called well-informed outcome, where we understand us as humans. So how do we get a well-informed outcome? So the test for this is quite straightforward. A well-informed outcome is that when you've written it, it's an absolute 100% yes. So you understand your experience, what your motivations are, your values, your principles. Yes, I need to do this. And we end up with a richer, better understanding of how our AI service or product is going to interact with humans, or how humans, multiple humans and multiple AI products are going to interact with each other. So some questions that are useful: describe what you want to do in the richest, deepest, most creative way possible. So there's a great example of a letter from Mozart where he describes in one side of A4 how he creates his music. And it's a really beautiful, by the end of reading this passage, you understand how he sees it, what he's thinking about, how it's going to sound, what he's feeling, and then this digital description of his kind of his checklist, his flowchart almost. And that's really what you want to do there at the start. Describe what you want to do in the richest, deepest, most creative way possible, visually, in a sound sense, an auditory sense, and your feelings. What are you going to be feeling when you're doing this? And then the digital part. Digital people tend to be kind of flow-driven, process-driven type of thing. You need to have that in there as well. Ask yourself, does what you're trying to do dovetail well with others? So is it, are you going to be using it on your own, or are you going to be using it with others and interacting? So collaboration, are you going to collaborate with other people? How are other people going to feel if you're using something that they can't use? So really get a rich understanding of how your AI system is going to work and dovetail with other people. What intangible resources will it take? Will it take goodwill, confidence, patience, discipline? These are human traits. And at the moment, if you think about machine learning, that's very objective, almost scientific. It's ignoring this human behavior, this human understanding. Is it ethical? Is what you're doing ethical? Are you going to, for example, if you design a traveling salesman program for delivering goods, say from popular websites, are you going to pitch your driver of the vehicle up against a machine? So the driver needs to go to the loo, the driver needs to rest, the driver needs to eat and drink, but you're going to place this driver, male or female, up against a machine, and all the machine needs is to be plugged in. Is it ethical? What you're doing is ethical, because ultimately that person will fail against them. How pure is your intent? Another way of getting a really rich understanding of what you're trying to do. I'm doing this to prove somebody wrong, rather than I'm doing this because it's ethical and it dovetails well with others. It's going to enhance other people's lives. We're going to improve the goodwill of other people. How pure is your intent? These are very human questions that can add a lot of value into the way you're building your AI system and your machine learning system. So examples of Hello Human AI. So home AI is a good one. How you're going to design your heating system, your power, water, entertainment. A lot of that's already been done. So entertainment is being done now by lots of online providers. Health and well-being. So how can you design your home AI system to improve your health and well-being? What about your safety? So security, home security is one, or just keeping you safe from fire alarms and things like that. Or improving how you work from home. Do you need a whiteboard? Do you need a smart whiteboard? So how are you going to design this AI system so that you have a better, more intuitive, almost like the airport, biophilic way of working from home that's good for you, reduces your stress. The next one is health, getting fit and well-being. So how are you going to design your AI system to improve your health? So become fitter, improve your well-being, whatever you feel it is. So better sleep, exercise, improving your focus. Human needs a self-maintained AI system that complements us. So it can't be forced. It needs to be something that complements and builds rapport with us. So we go back to it and trust it and use it. So these aren't easy. These aren't straightforward. You follow a process flow, such as you might do in machine learning. This is really understanding how the human's going to interact with your system at a much, much deeper level. How are we going to do this? Well, we need to understand as humans. And so far in understanding humans, we tend to think very much about but we don't really think about humans when we design our AI system. We may mimic humans, but then we don't think about how these AI products and services are going to interact with humans. What kind of behaviors are they going to instill? In the UK at the moment, we're talking about smart motorways, and really people understand smart motorways as adjusting the speed limit and removing the emergency lane that you would use if there's an emergency. And that's caused consternation for humans. We don't like it. We feel uncomfortable with it. The reality with smart motorways is we started off with the intent of controlling the speeds so that the motorways became safer, more traffic could pass safely through it, but also to control the environment for people living around motorways. So we wanted motorways to become quieter and less polluting so that people could have better sleep just before rush hour or in the evening. So some of the motorways in Birmingham reduce the speed when people are going to sleep. But smart motorways have now been misunderstood by the population, and we're thinking of getting rid of them because we think they're dangerous when we need to use the emergency shoulder. So it's a little bit more complicated than what we think. So machine learning is very easy. It's about learning from data. AI is about, well, we could think of it very simplistically as producing robots. But when we think about human-centric AI, we have to think about this ethical purpose. We have to think about it being trustworthy and reliable. So this is for you to think about away from this talk. Human being is more than IQ and EQ. Machine learning can give us superhuman skills. It can improve the quality of life, no doubt. But we humans are feeling, emotional, and conscious beings. And consciousness is an interesting one. Our brain has a conscious and subconscious capability. It interacts with chemical and electrical signals from our physiology, our environment, our memory, other people. And when you think about machine learning, we're not really talking about conscious and subconscious. We're not talking about how we interact as human beings with other human beings. How do we receive signals? How do we really learn? The human being is developed over evolutionary timescales. So we've chosen sight, so evolution has chosen sight, smell, hearing, taste, feelings as our data collectors, as well as less well-known ones, balance and acceleration. So vestibular ones, pain, internal, and hunger. And often humans use intuition to make decisions. So if you think of machine learning as just basically making decisions, well, actually we use our gut feeling sometimes. And we often relate emotions to our stomach or our hearts or our brains. So sometimes we can be very digital and we think everything's objective in our brain, or we can think it's with our hearts. We have a love and a passion for something, or with our stomachs, and our stomachs are generally associated with being brave, fight or flight response. And yet when we think about machine learning or AI, we've not really tapped into what human intelligence is, and certainly not thought about consciousness and subconsciousness. The latest thinking on consciousness is that it's nothing to do with intelligence. Why on earth is AI thinking about consciousness? But that's something philosophical to talk about elsewhere. If you're interested in what intuition, how powerful intuition could be, there's a YouTube TED talk by a gentleman called Magnus Walker. He basically as a child, he wanted to be design Porsche cars. And then in the 1970s, he realized he wasn't going to do too well in Sheffield. So he decided to just follow his gut reaction, and he ended up in America. He designed clothing. He ran a production company for producing movies and things like that. And he ended up finally, at the end of his talk, you find out that he did become a designer of Porsche cars. And he did all this by going with his gut feeling. And gut feeling is completely detached from artificial intelligence and machine learning. So there's a lot more to human-centric AI than we can think. Okay, thanks, Mark. If we have any questions, please take them.
Thanks, Andy. That's smashing. Yeah, thank you very much. That's absolutely fascinating. At the end of a long day of work, it still managed to get me really interested. So that's brilliant. I think you've met the first challenge for sure. We've had one or two questions here, so I'll just try and the first question, I'm afraid somebody had to leave. They've had a issue at work, and just to reiterate what we put on the chat, the meeting's been recorded and will be made available on the BCS members YouTube channel. One person has asked about the PowerPoint, the slides being available afterwards. Is that something that you'd be happy to do?
Absolutely. Yeah, I'll send them over to you. Yeah, that's no problem.
Smashing. Thanks, Andy.
Yeah, so the slides are there hopefully to give you a jump start in looking at AI in a deeper, more human-centric way. It's coming because of the EU. This is going to get written into law. So human-centric ethical purpose is going to be written into law. How they're going to do that, I don't know. But if you interact with Europe or if you interact with the States, it's pretty much going to track back to Europe. So they were the first to start thinking about AI guidelines. Other ones have started as well. The ISO, International Standards Organization. You've got El Silomar principles as well.
Yeah. Thank you. Oh, there we go. We've got a question that's come up. Let's go with that one first. What's the most compelling use case of AI in your view, Andy?
Compelling. Probably the one of a charity. So if you go to the Humans Plus Machine, there's a charity in India that has started to feed children at breakfast time to make sure that no child in India goes to school hungry, to provide the best kickstart for them. And they've used machine learning principally, but I'm sure artificial intelligence as well to do that. And they've gone from feeding hundreds of children to millions now. It's a really motivating, fascinating example of how they've addressed something clearly an issue in India.
Thanks, Andy. That sounds transformational. Sounds amazing.
Yeah.
We've got another question around the use of AI in safety critical systems, and safety critical systems examples given of avionics, nuclear power station controllers. You mentioned about your experience with, I think, nuclear power.
Decommissioning.
And so in terms of the challenges and solutions to those challenges, and any examples of AI working really well in those kind of systems.
Good one. How long is a piece of string? Nuclear industry is already regulated, heavily regulated, and you've got to do peer review. It's got to be open and transparent. They're just starting to work on it. So I think the last conference I went to on robotics, people at I think it's Liverpool University are starting to look at how can we test machine learning and AI solutions within the nuclear environment. So there are already, the nuclear industry is already what you describe as sustainable. It thinks about its waste from digging it up in the ground right the way through to disposing of it at the end. It manages its waste really well. They're trying to use AI to write safety cases by analysing previous safety cases and then coming up with a new safety case based on what they've learned. But again, you've still got to go through lots of peer review, and you've got to present this to regulators. So the ones that would be most advanced are probably the NHS and the pharmaceutical companies in terms of how they are using AI to justify their highly regulated processes. The nuclear industry is trying, certainly Sellafield are definitely trying to get AI into their decommissioning and their technology. But you've got to, it's a regulated environment. So you might go from TRL 1, which is technology readiness levels, it's on a bench in a university lab. TRL 9 is it's a commercial product. And then beyond that, you've got to nuclearize it. So that means it's got to come up to against the nuclear tests and facilities. But these industries are heavily regulated, and you've got to go through lots of formal processes in order to get it over the line. So, yeah, that's a difficult question to answer.
Yes.
Yeah.
You've made a good effort at answering it. Thanks, Andy.
If they have a specific question about an industry, about the nuclear industry, then I can point them in the right direction of people to talk to.
Sorry, Andy, didn't mean to interrupt.
Sorry.
No, I was going to say, in terms of a specific industry, you mentioned about the NHS being most advanced, and I suppose from a personal experience about working, supporting organisations that are doing or supporting themselves health and care research, where we've got a regulated industry as such in terms of research ethics committees that you mentioned earlier, and about determining whether or not a particular research research project has an ethical purpose. And the ethics committees are often like a real blend of lay people and experts. And I wondered, in terms of reviewing a kind of an AI based research project, what kind of skills do you think that ethics committee needs? Where do we need to kind of enhance our makeup of those committees and our skills in that committee makeup?
Wow, you're gonna
really hard question. Sorry.
It is hard, but my simplistic cartoon understanding of this is that you'll need the domain experts to tell you what's fit for purpose, and that's probably the critical element there. So the domain expert will tell you what's fit for purpose. What are they expecting this system to do? So the learning from experience has to do something, or the AI product has to do something, and how well does it do it? So if the domain expert will set those parameters, and the AI people on the surgeons or the experts in computer science or engineering have then got to design that system to what is fit for purpose for the domain expert. So the lay people, when you talk about the ethics side, that's kind of how far do we go with this? Can we treat everybody? And unfortunately, with resources and money, we can't treat everybody. So the NHS has got, they have to make very, very difficult decisions about what kind of treatment can be given as part of the NHS. The key people would be the domain expert, and then the AI experts, and the experts who are going to bring this technology to fore, or to provide this technology to make sure that it's fit for purpose.
Thanks, Andy. That's great. A couple more questions that have been coming in, and it's talking about metaverse. Then, given the hype, it says in the question, surrounding metaverse, which will have significant AI use, and the fact that the metaverse appears to be proprietary today, but actually some of the technologies you're focused on today, many of them are open source. Have you got any views on that open source versus proprietary tools and platforms, etc., in AI use?
Proprietary has got so proprietary, you're always going to have that air of doubt that it can't be peer reviewed intelligently. However, if you look at, so if you jump to 2045 and think about how would someone in the middle of Africa, in the desert, in 2045, we don't have cash anymore. It's a cashless society, universal income. Someone's come up with a really good idea of something that could add value to the world in some way. How do they justify that project and get the resources to do it if we don't get paid? So the idea of something like the metaverse, or being able to simulate something, it sounds a really sensible idea. If you're doing a machine learning project, or you want to design something, actually doing it in silico first, I'd use a phrase, in digital computing environment first, learning the big lessons, or generating the data so you can do some machine learning, whatever, that sounds like a really good idea. Company, and I know people talk about the metaverse, etc., and it could, if it's just a virtual world and it's not changing people's behavior and they're learning from it and it's useful, that seems like a good thing. And there's usually two options when people talk about the future. Are we going to go for utopia, or are we going to go for dystopia? And what happens if you go for utopia? The metaverse goes for utopia, but we get it wrong. This is an example that Stuart Russell often comes up with and says, we set off in the right direction, but we get it wrong. Is there an AI off button? So in principle, the metaverse seems like a sensible idea. We're allowed to simulate things in a simulated environment. And as long as it's not hurting people or generating bad behavior or something, that seems like a good way for people to learn. And it's almost like a utopian idea. But we need to have the AI off button. We need to be able to switch it off if it goes wrong. So someone needs to be there to be able to say, no, that's unacceptable. We need to switch off. A bit like AI. So if you read Max Tegmark's book on Life 3.0, he says we only developed the fire extinguisher after we discovered fire. So maybe we should be thinking about switching off the AI should it get out of hand and go wrong. But at this moment in time, it seems a good opportunity for us to solve some pretty critical problems, such as genetic healthcare, climate change, for example. It could help us with climate change, understanding our genes better, or protein folding that's come out from DeepMind. These are really good good sales pitches for AI, really.
Yeah, that's struck a chord with me, remembering in terms of the off button, remembering teaching my stepdaughters how to drive and showing them the brake before the accelerator, I guess, is a real life example.
That's right.
My
daughter turns 17 next year.
Oh yeah, well, good luck with that.
Yeah.
Another question about, you mentioned about AI potentially creating safety cases. Is there any more information or any signposting on that you could do?
Go and have a look at, it's a website by National Nuclear Laboratory. It's Game Changers, and they had a call for people with AI capability to develop safety cases. I've forgotten that probably about a year ago, maybe 18 months ago, they had a call. I don't know where they're up to with that. They haven't published anything just yet. I think this was a kind of like a throw out, to a general calling to see what was out there in the real world, and to see whether or not they needed to develop it themselves or not. But it's out there. It's called Game Changers from National Nuclear Laboratory, or Fizz 360, maybe another place where you could go and have a look at it. You know, whether that's going to work or not, I don't know. When you look at things like the chatbots that were let to run freely, ended up being rude and racist and whatever. So whether that's going to work or not is it's good to try it. Yeah.
We'll be learning from experience, I guess.
Correct. Yeah, proper learning from experience. Yeah.
I know we've run out of time. If I might ask one last question in terms of the world of AI, what do you think? What's your prediction, Nostradamus of AI, that you might be, Andy? What's going to be the next big headline that springs from this world of AI, do you think?
Oh, wow. Realistically, as an engineer, we'll explore space in more depth. We'll make something habitable on Mars. So we'll send robots out there to provide the environment for us, and that will involve lots of AI robots of some description. Whether or not we'll have this utopian view, I don't know about the utopian view, but space, the fifth industrial revolution looks like it's going to be space, and I think AI will have a big impact on that, because we'll have the robots to go out there and do it in space and provide the environment.
Sorry, go on.
It provides the environment for us in the future. Yeah.
In a world where COP26 has just finished, that we might need to be looking off world, I guess, for some of the solutions. That sounds quite promising and relevant. COP26,
they made it sound so easy to get down to 1.5 degrees. We'll see.
You referred to the sustainability of AI earlier, and I'm sure that's again, all very topical, really, isn't it? In terms of what we all need to be thinking about.
With that, it's unfortunate we tend to make machines more efficient to grow the capacity. We don't do it to use less energy. So the average speed of traffic in London is about the same it was as the start of the last century. It's just that 6.5 million people travel on the system now, whereas a few thousand back at the turn of the last century. So we tend to make things bigger and worse. So the efficiency that AI may help us with may not necessarily help us with climate change.
I'm aware of time, and people will be dashing off for the tea. No, I can say tea, knowing that we're in as a Northwest BCS group rather than dinner. And on that note, I'll just post a link to our LinkedIn group on the chat if anybody's interested and not signed up there. And just to say, to round it off then, Andy, thanks so much for that fascinating talk. Brilliant. I'm really kind of such a great breadth and depth of points that you covered there, as well as fascinating answers to the questions too. So thanks for your time.
Thanks for having me, Mark.
And thanks to all of you, everybody who's joined this webinar as well. It's been great to have your questions and to have your attendance and your interest as well. And look forward to maybe seeing you in future branch events too. So to bring that to a close, hope you all have a great evening, and we'll see you again soon. All right. Thanks. Bye-bye.
Bye.